So dear, back to our, and today we are going to the second class of time. Topic is speed. See here, speed is equals to speed is distance traveled with during some time interval. As we have seen A and we have suppose it is path 1, it is path 2, path. The distance is the path followed by the object is, and the displacement is the shortest separation between. And yesterday I had told you considering as distance and displacement both, but these are the and the time taken to travel through either of these distances is, now the speed is equals to the distance traveled by time, and velocity is equals to displacement by time. Displacement by time. Displacement means from here to here, the shortest path. So this is the displacement, and we can represent the direction also. Yes, the direction also, and this gives displacement time. Now, next concept is average average speed. Average. Let us see. Suppose this is position vector r. This is position. Now this will be okay. And suppose object starts its journey and coming up to, now average speed is equal average speed is equals to, suppose at a time t1 object is at a time time t2 object is look. Now speed is equals to distance traveled by t2 minus time taken to travel here to here, and this is what is average. Then next one is average velocity. Average average here average velocity. This is r1, r2, delta r, and r1 plus delta r is equals to, then delta r is equals to r2 minus, this is the displacement. Okay, this value is this. Now average velocity is equals delta r by delta t, that is r2 minus r1 by t2 minus this is what the average speed and average velocity, right? Now based on this, let's see. First one is a train travels from city A to city B with a constant speed of 10 meter per second. Let it be city B. Now it is traveling from city A to a speed of 10 meter per, and return back to the city A at a constant speed of 20 meter per second. It is moving back at the speed of 20 meter per second. Then they are asking us to find what will be the average speed during its journey. That means the formula for average speed is equals to total distance by total time. Total. Now let us see the time here is the time t here for the return journey is, the separation between these two is now the total distance traveled here. You have to understand one most important point. the total distance traveled. That means the total path traveled by the object is s while it is traveling from B. Similarly, s when it is traveling from, then total time is equals to 1 plus. Now, can I write T1 plus T2 plus here? We know velocity is equals to s by t. So t is equals to by velocity. That means s by t1. That is when it is moving from A to B. Now s by t2 moving from A. Here that means here 2s. Yes, I am taking common b2, t1, b1, b2. Then yes get cancelled. Will be 2v v2 v1 plus v2. So average speed equals to 2 into 10 into 20 by 10 plus 20. That is 400 by 30 or 40 by 3 meter per second. This is the answer for 10. Second, similar to the here we are discussing different models of the question over the same concept, and we have seen a conceptual problem that when separation between the two locations are same, that is from A to B and B to A, average velocity, average speed we found when the distance traveled is same in to and fro journey. Here now second point, let's see one more question. In this question, car moving in a straight line moves with a constant velocity. Car traveling in a straight line moves with a constant velocity v for some time. Suppose it is traveling from here to here at a time t, let's say time t, with a velocity v1 for some time and with constant velocity v2 for the next equal time. Next equal time. Before that, we will discuss a question which says to and fro journey with equal distances, equal separations. Here the question is equal times. So here you must consider travels from here to here with the velocity of v2, here to here with the velocity of v1, here to here with the velocity of v2, but time interval is time interval remains same in equal time. Then they are asking us what will be the average. Now average velocity equals to average velocity is again displacement traveled by time taken. Okay, displacement traveled by time taken. Here, can I say displacement? Let it be. So this will be s1 plus s2, and time is t plus t. T plus. Okay. Now, can I say s1 is equal to velocity into time? Velocity into time v1 t plus v2 t by 2t. That means v1 plus v2 into t by 2. That means these two will get cancelled. v1 plus v2. This is what is the second question. And we were discussing one conceptual problem with the same separation to and fro, one conceptual problem with same time interval. Now we will see the third question, which covers both the concepts. See here, a point transfers half the distance with a velocity v naught. That means object starts with and half the distance with a velocity v naught is traveling from here to here. Let it is yes, let it is total distance as for our convenience. Okay, and velocity when it is traveling from A to B is A to B is v naught, and the remaining part of the distance was covered with a velocity v1 for half of the time. That means, suppose time taken each from here to here. Let us assume time taken each from here to here. So, now half of the time with a velocity v2 covered with a velocity v half of the time. Suppose t2 by 2 time is traveling the velocity v, and with the velocity v2 for the half remaining half. t2 by 2, meaning half of the time, travels with the velocity v2. Okay, find the average speed of the point. Right. Now they are asking us to find. They are asking us to find average speed. Average. Now total distance by total time. Total time. Now we can say total distance is yes, total time T1 plus T2. T2, right? T1 from here to here, T2 is from here to here. That T2 has been resolved into two components, T2 by 2, T2 by 2 with the velocity, T1 with the velocity here, right? Now, let us say T1 is equals to T by S, T naught by S from here. Am I right? Then, similarly, S is equals to, this is from A to B, A to B. Now, from B to C, understand it, B to C traveled is equals to velocity into time. That means velocity is V1 into T2 by 2 from here to here, here to here, again V2, T2 by 2. Can I write like this? Yes, displacement or distance or displacement because of rectilinear or straight line motion. Then S is equals to V1 by 2 plus V2 by 2 into T2. I took T2 as a constant, right? This gives T2 is equal to 2S by V1 plus V2. Any doubt here? I hope I am clearly explaining each and every part. Very minute points also I am. And see here, we had already seen that V1 is equals to V0 by S, V2 is equals to 2S by V1 plus V2. Then average speed is equals to total distance 2S by T1 is V0 by S and T2 2S. Then here is S by V0 plus 2S by V1 plus V2. Clear? Now this is 2 by common 1 by V 2 by V1 plus V2. Yes, get cancel. 2 by 1 plus 2 plus 2 V0 by V1 plus V2, 2 V0 V1 plus V2 by V1 plus 2, 2 V0. This is the average, and this is a type of critical problem for the concept of speed and velocity. I hope here from my side. And next here, fourth question. Wait for 1 minute. It be refreshed. Meanwhile, I will be refreshing again. Hmm. Right. Then fourth question. This question is actually I am discussing again to recall the topic which we were covered in our last class. Topic is first, I am recalling the vector concept by using today's class. Right now, the particle moves so that its position vector varies with r is a cos omega t I plus sin omega t. Question A is initial velocity of the particle. The initial is initial at time t. Now velocity is equal to change in change in position by change in time. What we have seen that as change in position by change in time. If it takes place at infinitesimally all time, we can write it as in terms of derivative as dx by dt. Now the velocity will be d by dt of the position vector they given as a cos omega t I a sin omega t a. Now by differentiating this a omega sin omega t I this a omega cos omega t a, and they are asking initial velocity mean at t is equal to 0, this will be minus a omega sin 0 I this a omega cos 0 a. Okay, now this equals to sin 0 is equals to 0, then 0 plus a omega cos 0 is equals to 1, then velocity is equals to a omega at time t is equals to 0. The first one. Now, second question. In question, second part is angle between the position vector and the velocity vector at any time. Now, position vector is r is equal to, given position vector is a cos omega t I plus a sin omega t a. The given velocity vector is minus a omega sin omega t. I found just now here plus a omega cos omega t a. And here two vectors are given, and they are asking us to find the angle between the vectors. Can I use the scalar product which we were covered in our last class, before last class? So by using scalar product process, cos theta is equals to vector A by vector B, magnitude of vector A, that means can I write now cos theta is equals to vector A, let us assume position vector A cos omega t I plus a sin omega t a into a velocity vector minus a omega sin omega t I plus a omega cos omega t a. Okay, and here magnitude of a, magnitude of b, I will discuss while I am writing just a and b only here. See, I dot I equals to 1, I dot j is equal to 0, which we have seen in our last class. Then a, I am multiplying this with omega cos omega t, and here negative sign is plus. So I can write it in negative plus a, and I am multiplying this to a square omega sin omega t cos omega t by magnitude of a, magnitude. Okay, and obviously these two will get, that's why I am not writing magnitude here. Ultimately it gives 0, and when two vectors are having 0 as their answer, when they are perpendicular to each, is a dot b is equals to ab cos 90. That means if they are perpendicular to each other like this, then the angle is, which gives a dot b answer as 0. That means here also we got angle between position vector and position vector and velocity vector as, therefore position vector and velocity vector are perpendicular to. Okay, I hope I am very clear for the second point. The third one is speed at any instant. Understand the question very carefully. They are asking us the speed. What is the speed represents? Speed represents the magnitude. We have velocity cos I plus omega minus a omega sin omega t I plus a omega cos omega. This is the velocity vector. Now they are asking only speed means they are just asking us to find the. That means here a omega whole square plus a omega cos omega t whole square. That means here a square omega square sin square omega t plus cos square omega. Now this will be under root of a square plus omega square or a. This is what is the speed. This is what is the. I hope. And again, I discussed the concept which we were covered in our last class also for your to improve the strength of the. Okay. Then next one is acceleration. What is acceleration? See here, suppose object starts its journey, it reaches this. Suppose here it is having velocity. Here it is. Now the time taken to reach from here to here. Let us assume that means here we have two cases. Number one is acceleration. Acceleration means as time passes, the velocity of the object is increasing. That means in this case, v2 is greater than. If it is the case, we can say that the object is accelerating. So we can say acceleration is equals to change in velocity by change in t2 by t1. Suppose if it is starting with. This is what is acceleration. Similarly, if v1 is greater than v2, that means as time passes, the object's velocity is decreasing with respect to initial position. Then retardation is equal to v2 minus v by t2 minus t1 only. But as v1 is greater than v2, we will get negative answer. Acceleration as retardation. Now, for again your just us solve problem. A drag racer crosses the finish line and the driver deploys a parachute and applies the brakes to slow down as shown in the illustration. The driver begins slowing down when time t1 is 10 seconds and as car's velocity is at this location. Time t 15 seconds, 15 seconds. This location, his velocity is 15 meters per second. Let us say what is the average acceleration of the acceleration is equals to, we know the formula t2 minus t2 is 15, t1 is 20, t2 is 15, 10. That means can I say minus 10 by minus 2 seconds. Now the answer is representing in terms of negative. The object is getting, yeah, the object is getting retardation. Then next one is right. A particle describes an angle theta in a circular path with a constant speed v. That means the object is circulating through this curve with the speed of v. With the speed of v, then find the change in velocity of the particle. Change in velocity of the particle. See here, object is dislocated. Velocity vector will be velocity vector is when the object is at dislocation, its velocity vector will be right. Now, change in velocity is v2 minus. Here, the magnitude of the object remains the same. That is, speed remains with a v, right? The magnitude remains the same, but vector's direction is changing. That's why even the magnitude remains the same for the vectors. If their direction is changing, the vector values, the velocity values will be v2 minus. Now they are asking us to find the change in velocity of the particle. The change in velocity is delta v to the root of v2 square v1 square minus 2v2 v1 cos theta. Okay, cos theta. And the angle is between v1 and v2 is theta. They represented it as theta. Now, see here, according to our vectors concept, this v2, v1, while we are writing to the resultant, these are the magnitude values. That means, can I say here, of course, here they mentioning with, but vectors have and their magnitude. That means, can I say here, e square plus v square minus 2e square cos theta, right, like this. I hope very clear. And if you have any doubts, you can. I will definitely say in our next. Then next one is 2v square 1 minus cos theta, and by using cos theta is equal 1 minus sin square theta by 2. This is equal to 2v square 1 minus 2 sin square theta by 2. These two will get cancelled. This will be 4v square sin square theta by 2, or I can also write it as the root of 2v sin theta by 2 whole square. These two will get cancelled. 2v sin theta by 2. 2v sin theta by 2. This is what is change in, got my point? Average, then change in velocity we found. And they are asking us to find what will be the average acceleration of the average acceleration. Here, what is the average acceleration formula? That is change in velocity by time. Change in velocity by time. Time means the time taken to travel from here to here. Can I say now, if it is circulating like this, can I say time taken is equal to time taken to distance by speed? Can I say like this? With certain amount of speed, the object is circulating or moving. Now distance traveled by speed. The distance is equals to arc length, arc length by speed is v. The given in the question speed is v. Here the arc length is, can I say arc length as arc length as r into theta. Arc length is equals to r theta by r theta by v. This is what is time, and I am substituting this here. Now 2v is equals to 2v is equal delta v is equal to v sin theta by 2, and time is equal to r theta by. Therefore, acceleration is 2v square sin theta by 2 by r theta. This is what is the acceleration by using vector concept. I hope you understood the strongly, and I think I am helping you as much as I can. And if possible, you can comment me whatever the doubts you have first point, because my intention is to give you the 100%. upcoming competitive examination. And even if you want daily practice, weekend examination, follow me channel Physics with Jagan sir. Have a great day. Take care.